Hey guys, welcome back to the channel. So today we are going to see the part 1 of Tsgctf write-ups. So the first challenge we are going to solve is the upside down cake. So in the description we are given the URL for the challenge and also a zip file for the code. So let's open up the challenge. So opening up the challenge, we can see that we are being asked for a long palindrome to get the flag. First let's send a small palindrome and see what will happen. So here we can see that we are getting a message saying too short. So let's check the code for the logic behind the website. So here we can see once the palindrome is sent to the server, it is being passed through the valid palindrome function. So in the valid palindrome function, we can see if the string length is less than 1000, then it will return too short. So this too short string will be stored in the error and this error will be sent as the response. So if we want to get the flag, we have to pass a string which is greater than 1000 in length. So let's use Python in order to create a payload of all A's of length 1001. So according to our assumptions, copy pasting this payload into the website should get us the flag. But when we try to submit this, we are getting an error saying request entity too large. This is because of the client max body size attribute which they have set in the ngx.config file. As you can see here, we can send only 100 bytes in a single request to the server. So the workaround for this challenge is to consider the string as an object. So what we can do is we can create an JavaScript object in which we will have an attribute length which is set to 1000 or 1000 above, and also have the attributes 0 and the length -1 set to a same character. So to check if this works, I wrote a new line of code to print the string.length. Now let's start the server locally and try to exploit it. So we can see here that the server is proper and is up and running. So let's try to intercept all the traffic using Bubsuit. Now that we got our request, let's send this to repeater. In here, let's change the palindrome parameter to the object which we initially thought of changing it to. So once we send this request, we must be able to see the flag. So here we can see that we are able to get the flag. In here we can also see that the print statement which we wrote worked and is printing 1001. And because of this we are able to bypass the if statement and return null. Now let's try sending the same data to the actual challenge server and see if we can get the flag. So as you can see here, we are finally able to get the flag. Now let's solve the second challenge of the CTF, which is dance. So initially when we open up the URL, we can see that there are no cookies set, but when we press guest button, we can see that there are few cookies getting set in the website. So to be accurate, there are 3 cookies, auth, IV and tag. All are URL encoded after they are being base64 encoded. So now let's look at the code. So they have given us a PHP code in which they are requesting auth data using post method. So at the bottom of the page, we can see that there is a form, and when this form is submitted, it will send the auth value set to guest to the server. This means that this particular block of the code will be executed. But in order to log in as admin, we not only have to send the auth value set to admin, but we should also send another parameter called password, which should have the same value as that of an unknown variable flag. But if both the conditions are failed, we'll be redirected to index.php. So there is nothing much we can do with this code. So let's check the other page which they gave. So here we can see that there's a cookie named auth, and when this cookie is decoded, and if we are able to get the value as admin, then we'll get the flag. So what we can do is we can tamper with the cookie and change the value in such a way that the encrypted value is not that of guest but that of an admin. So the AES 128 GCM algorithm uses XOR between key and the plain text in order to get the encrypted text, and it also verifies this particular encrypted text using the tag variable. So what we can do is we can use a bit flip attack, as we know the plain and the encrypted texts, to get the key. So to give a demo of how this attack works, let's just take a value guessed, and using this binary key I'm going to encrypt this value. As you can see here, we got the encrypted text. Now let's try to use this particular encrypted text as the key and try to do the encryption. So this value which we got is nothing but the binary key but in ASCII form. To check this, let's just quickly use a converter and see what will happen. As you can see here, both the initial binary key and this value are same. In our case, the guest is XORed with the key to get the encrypted text, and to get back the key, what we can do is we can XOR both the encrypted and the plain text. I wrote this Python code to do the work for me. So once we get the key using the technique which I told, we can XOR the key and the admin value to get the final encrypted value which we want. But we still have a problem, the tag variable. The tag variable verifies if the cookie is tampered with. But in PHP, there's a vulnerability in OpenSSL decrypt function, in which the developer has to explicitly check for the length of the tag, but in the given code it is not checked. So what we can do is we can have a single byte of tag and we can brute force it from 1 to 256, and somewhere or the other we can exploit this vulnerability. So this loop is for the vulnerability which I mentioned just now. So we can run the script and it will try out all the different possibilities for the tag variable, and somewhere in the between we'll be able to get the flag. So as you can see here, we are finally able to get the flag. Thank you for watching guys. Please do like, share and subscribe, and watch out for part 2.